The last video for this chapter is going to focus on mountain building, which is called orogenesis. Oro means mountain, genesis means birth. So the term orogenesis just means the birth of mountains. And when we're looking at different mountains across our planet, they'll have very different shapes to them. Generally, the older that our mountains are, the more time has passed since they formed, and they're more heavily eroded. So they're not going to be as tall topographically as a younger mountain chain would be. But we're going to see that our mountains primarily form in two different ways. One is from a collisional movement. This generally happens when we have our convergent plate boundaries, where two continents are colliding together, and it's going to force those two continental plates upwards into a mountain belt. In doing this, as the mountains are created, it's going to be creating lots of faulted and folded rocks along the surface as well. If we look at a map of our planet, we'll notice that a very large proportion of our continents are covered in mountains, but these mountains really vary in their age. Some, like the Himalayas, are forming right now. Others, like the Appalachians, can be up to 1 billion years old. But remember, we can get mountain ranges, like the Appalachians, forming from collisions with other continents. So we actually see that the mountain ranges in northern Europe and the ones that go through the northeast of America all formed during a continental collision at a convergent boundary about 1 billion years ago. But we have other mountains that form due to some subduction. It's still at a convergent plate boundary, but we're going to have a plate subducted and forced back into the earth. Eventually, that subducted plate is going to get deep and hot enough it's going to melt into magma and rise to the surface, creating volcanoes. So some locations around our planet, like the Andes Mountains, these are created because of subduction. We're forcing the Pacific plate to subduct underneath South America. The Pacific plate is melting and it's forming mountains along the edge of this continent. In order for subduction to occur, we need at least one oceanic plate to be converging. If we have two continental plates converging, it's just going to create a mountain belt. But as long as we have at least one oceanic plate, it will subduct. As it's being pushed back into the earth, it's getting deeper and hotter where it's going to melt into magma. That eventually will rise to the surface, creating a chain of volcanoes. But it can create different types of volcanic arcs on top of the overriding plate, depending on whether that overriding plate is continental crust or oceanic. If it's an oceanic plate subducting underneath another oceanic plate, it's going to create a volcanic island arc. These are still mountains, even though they're islands, because it's just a volcano that's grown in size to the point it's above the sea surface. But we can have other volcanic mountains forming if we have an oceanic plate subducting underneath a continental plate, which is what we saw with the Andes Mountains in the last slide. So with these mountains, a lot of people will get confused that I'm calling volcanoes mountains. All volcanoes are mountains if they're tall enough. A mountain has a really generic definition. It just means something that's significantly higher in elevation than the surrounding areas. And this final slide is just showing us how that subduction looks when we have two oceanic plates colliding and the older, colder one subducting. It's still going to subduct, melt, and form volcanoes, but now because it's forming volcanoes on top of an oceanic plate, we call this a volcanic island arc instead of a continental volcanic arc.